The Tesla Semi has always been incredibly impressive with its beast-like performance, but that's definitely not where Tesla plans to stop. All current Semi trucks are prototype versions delivered to select customers for testing and data collection before Tesla finalizes the design and begins mass production at its new factory. Recent leaks suggest that the Tesla Semi is about to undergo some significant design changes, especially when it comes to the headlights, hinting at the upcoming debut of the Tesla Semi version 2. We know these changes might be controversial, but many customers are likely to welcome them. Right now, let's dive into what's new with the Semi Truck version 2, look at some real-world testing results, and check out the latest updates on the Tesla Semi factory. Welcome to Tesla Car World. Among all of Tesla's EV models, if there's one that truly challenges the laws of physics, it has to be the Tesla Semi. Normally, a semi-truck with a total load weight of up to 80,000 pounds would have very poor performance. That's why electric trucks have long faced skepticism from industry experts. Even Bill Gates once argued that despite major breakthroughs in battery technology, electric vehicles are unlikely to be a practical solution for heavy-duty transportation, like 18-wheelers, cargo ships, or passenger planes. His reasoning was that batteries are simply too bulky and heavy to meet the demands of long-distance freight. Gates claimed that batteries couldn't power such high-strength, long-range vehicles effectively. However, Elon Musk bluntly pushed back, saying Gates didn't know what he was talking about when it came to electric trucks, especially when he claimed that heavy-duty engines couldn't run on batteries. To prove Gates wrong, Tesla didn't just build a regular electric truck. Elon Musk is aiming to revolutionize the entire trucking industry. The Tesla Semi is designed to be so groundbreaking that it could actually convince truck drivers to stay in the profession at a time when the U.S. is facing a growing shortage of drivers. For the first time in history, an electric truck can travel up to 800 miles when unloaded and save up to 1 million gallons of diesel, the equivalent of $3.5 million in operating costs. That's why Elon Musk has always referred to the Semi as a money-making machine. However, the Tesla Semi has been stuck in limbo since its debut in 2017, nearly 8 years, due to a variety of reasons. To date, only around 500 units exist, with half delivered to customers, and the other half retained for internal use by Tesla. One major reason for the delay in mass production has been the need to gather real-world data from customers. Tesla requires feedback from PepsiCo and other early test clients over a minimum 2-year trial period before finalizing the truck's production design. The testing phase not only helps Tesla refine the design, but also serves as a critical opportunity to evaluate the Tesla Semi's performance under real-world operating conditions. The data gathered from major customers like PepsiCo provides valuable insights into how the truck performs outside of controlled environments. So even though the Tesla Semi was unveiled several years ago, mass production hasn't happened yet because Tesla has been waiting for customer feedback before making final adjustments. Naturally, no one would be reckless enough to mass produce a vehicle that isn't fully developed. It would be full of issues. That's why, now that the Semi production facility is nearing completion and the testing phase with logistics companies is wrapping up, Tesla has revealed several changes to the Semi compared to the original prototype. Zangler, a Tesla Semi supporter who regularly shares updates on the electric truck and the construction progress of its factory through recent drone footage, has captured a video of a Tesla Semi wrapped in shrink film. As a longtime Semi follower, he believes this could be a refreshed version of the big rig. It's not too hard to spot that the front end, bumper, and overall lines appear more pronounced and noticeably different from the current version. This hints at a new LED light bar design, similar to what's seen on the Cybertruck, Cybercab, or Model Y, possibly being implemented in the Semi version 2. To help visualize this design, we created a render of the Tesla Semi with its standard headlights replaced by an LED light bar. Yeah, and here's the result. What do you think of this new design? Let us know your views in the comments below. We think this design looks modern and aligns well with the design direction Tesla has been pursuing. Hopefully, the refreshed version will look like this, because in our opinion, the Semi looks much better with an LED light bar than with the current headlight setup. We're really looking forward to learning more about version 2 of the Tesla Semi. Beyond just the headlights, Dan Priestley has confirmed that a few other things will also be refreshed. Here's what he said last month.
We have a new mirror design. Better sight lines, better aerodynamics, better performance overall. On top of that, we added a drop glass. There's a lot of fixed infrastructure, whether it's gate operations or interacting with a port or a telecom. These will make drivers' lives easier. And then one other thing, we have a new HV battery. Now this battery brings in our latest and greatest in terms of technology. It is cheaper to manufacture. And the best part is that it's actually less battery energy than in our current pilot production vehicles. But it maintains the same range. This is achieved through efficiency improvements that we're showing here, more than 7% at this point.
These are just a few minor updates. We believe there are many more changes in the works that Tesla isn't in a rush to reveal. What we've seen so far is just the beginning, and there are certainly plenty of other improvements Tesla is keeping under wraps for now. Even as a prototype, the Tesla Semi has already proven its outstanding capabilities, not just in testing, but also in real-world conditions. One of the key factors that has propelled the Tesla Semi to the forefront of the electric truck segment is its impressive performance, outperforming every competitor in its class. However, what truly sets the Tesla Semi apart is its real-world range, a number no other electric truck has come close to matching. From traveling farther on a single charge to maintaining consistent performance even under the harshest conditions, the Tesla Semi continues to raise the bar. It's more than just an upgrade starting next year. Customers will have the opportunity to own the Tesla Semi at a lower price point. Elon Musk has unveiled a groundbreaking plan for this heavy-duty truck, offering customers an unprecedented level of flexibility. Instead of offering only a single version with a 500-mile range priced at $250,000, Tesla will now allow buyers to customize the truck's configuration based on their actual needs. This means that if your daily driving range is only around 250 miles, you can pre-order a Tesla Semi specifically designed for that use case. In our view, this program offers tremendous benefits for transport businesses, especially those that don't require long-haul capabilities. They'll be able to significantly reduce costs by choosing the basic version, priced at around $170,000. This isn't just a major step forward in making the Tesla Semi more competitive. It also opens the door for more businesses and drivers to access electric vehicle technology, accelerating the transformation of the transportation industry. In the past, transportation companies looking to own a Tesla Semi had to pay a premium for the standard version with a 500-mile range, even if their daily needs were limited to short routes like urban deliveries or regional transport. This created a financial burden for many small and medium-sized businesses, especially when they couldn't fully utilize the truck's high-end features. However, with Tesla's new configuration options, the Semi can now be tailored to fit the real-world needs of each business. For example, base versions with a range of 250 to 300 miles are now available, ideal for short-haul operations. This added flexibility allows customers to avoid spending on features they don't need, while still benefiting from the core advantages that make the Tesla Semi so appealing: low operating costs, powerful performance, and eco-friendly design. Even the base models retain Tesla's standout qualities: a durable electric motor, impressive acceleration, and an aerodynamic design that boosts energy efficiency. By scaling back certain high-end features like extended range and advanced driver assistance tech, Tesla has significantly lowered the upfront cost, making it easier for more businesses to adopt and invest in electric trucking. Here are some PepsiCo drivers' experiences sharing about Tesla Semi.
Well, I've been driving it for about 3 or 4 months now. And yeah, we get questions every time we go to a different facility. People see us, long haul drivers, they ask questions, and I tell them it's just, it's so comfortable, it's so easy to drive. You're so close to the front of the tractor, your visibility is amazing.
I do about 400 plus miles a day. Being in a good truck, comfortable, drive great, it makes a world of difference on my day. I don't hurt as much.
It's better than in my car. It's a lot more comfortable. They're quieter, they're smoother, they look nicer. They don't look as intimidating.
So far, to our knowledge, Tesla Semi has been delivered to at least 7 major transportation companies, including PepsiCo, DHL, Martin Brower, Costco, Saia, Walmart, and WattEV. Most recently, ABF Freight, a division of Arc Best, completed Tesla Semi testing with impressive results, further confirming that the Semi is a fully capable electric truck. According to reports, ABF Freight successfully completed a 3-week pilot program testing the semi-truck and road transport applications. ABF Freight released the results after testing the Tesla Semi over nearly 4,500 miles. They provided detailed information in their report stating that, over a 3-week period, ABF operated a Tesla Semi across typical dispatch lanes, including over-the-road routes between service centers in Reno, Nevada, and Sacramento, California. The pilot also included regional runs in the Bay Area and rail shuttle operations. The electric Semi logged 4,494 miles, averaging 321 miles per day with an overall energy efficiency of 1.55 kilowatt-hours per mile. The results of this latest trial show significant progress. Firstly, with nearly 4,500 miles and an average of 321 miles per day, the Tesla Semi is not only suitable for regional routes, but can also operate efficiently on long-haul routes. This is noteworthy because among the electric trucks available globally today, the Tesla Semi is nearly the only one capable of serving long-distance transportation, thanks to its ability to travel up to 500 miles on a single charge. Currently, no other electric truck on the market can achieve this. This is why we confidently assert that the Tesla Semi is the only electric truck currently suitable for long-haul transportation needs. In the 2023 Run on Less event, manufacturers such as Tesla, Freightliner e-Cascadia, and Volvo VNR participated with their electric truck models. The real-world test results show that a Tesla Semi can cover up to 1,076 miles in a single day. Meanwhile, PepsiCo's Tesla Semi fleet recorded an average of 613 miles per day. In comparison, the Freightliner e-Cascadia fleet from OK Produce only managed 204 miles per day. The total distance covered by PepsiCo's fleet exceeded 27,000 miles, while the second-place fleet using Volvo VNR only covered about 5,200 miles. The performance gap is clear and impressive. Meanwhile, the total distance covered by PepsiCo's Tesla Semi fleet exceeded 27,000 miles, while the second-place Volvo VNR fleet only managed about 5,200 miles. This discrepancy demonstrates that the Tesla Semi is leading not only in range, but also in operational efficiency under real-world conditions. As we mentioned earlier, the Tesla Semi can achieve a range of nearly 800 miles when unloaded and 500 miles when carrying a total weight of 80,000 pounds. This is due to the truck's large battery pack, which has a capacity of 850 kilowatt-hours, with an efficiency of 1.55 kilowatt-hours per mile, as recorded by ABF. The Semi can easily complete a 321-mile trip on a single charge, with enough battery left to travel at least another 220 miles. An efficiency of 1.55 kilowatt-hours per mile is a very impressive figure, significantly better than previous test results from other companies, which averaged 1.7 kilowatt-hours per mile. Not stopping there, ABF Freight's report also stated, the vehicle performed well across a variety of routes, including the 7,200 climb over Donner Pass, and generally matched the performance of its diesel counterparts. Driver feedback was positive, with operators noting the vehicle's comfort, safety, and ease of use. Features like the center seat configuration, wide visibility, and intuitive controls contributed to strong driver experience. Elon Musk has emphasized the acceleration capabilities of the Semi multiple times since its launch. Steep hills and inclines have never been a challenge for the big rig, even when fully loaded.
Okay, the best diesel trucks can only do 45 miles an hour up a 5% grade. Tesla Semi can do 65 miles an hour up to 5% grade.
The Tesla Semi boasts superior torque and acceleration capabilities, especially when climbing hills. Even when fully loaded, the Tesla Semi outperforms diesel trucks. As far as we know, the Semi is the first electric truck capable of climbing a 10% grade at 60 miles per hour while carrying a full load, a feat no other truck globally can match. In comparison, traditional diesel trucks carrying heavy loads often crawl at around 30 miles per hour on highways, causing traffic congestion and excessive fuel consumption. Beyond that speed, they risk tipping over at any moment. Regarding driver feedback, it's clear that drivers have echoed the same sentiments as those from PepsiCo, all highlighting the excellent interior space, driving experience, and visibility. The Tesla Semi version 2 promises to completely transform the transportation industry with advanced features, including full self-driving capability with supervision. This feature has been tested multiple times and has shown positive results, bringing hope for a future where autonomous vehicles become an essential part of the roads. The integration of FSD in trucks not only enhances safety, but also addresses one of the biggest issues currently facing the transport industry, the shortage of truck drivers. By automating the driving process, the Tesla Semi can ease the burden of labor shortages while reducing traffic accidents related to human error, making the roads safer. With its potential for global operation, The Tesla Semi is not only a solution for the US market, but could also expand to many countries, including Europe. This is especially significant as the demand for freight transport continues to rise, and reducing emissions in the transportation sector becomes a key goal. Tesla has proven its potential in creating vehicles that are not only smart, but also environmentally friendly. According to Elon Musk, traditional trucks make up about 1% of all vehicles on the road, but contribute to 20% of global emissions. Therefore, if the Tesla Semi succeeds, it will play a crucial role in reducing emissions from the transport industry and contribute to a cleaner environment. Tesla's introduction of this electric truck is also a major step in accelerating the global shift to clean energy. With advanced design, superior performance, and self-driving capabilities, the Tesla Semi is not just an electric truck. It is a symbol of an industrial revolution in the transportation sector. It not only addresses economic challenges, but also offers significant environmental benefits with the potential to reduce dependence on fossil fuels and minimize air pollution. Moreover, the Tesla Semi could help reduce operating costs for transportation businesses. With lower maintenance costs compared to traditional fossil fuel-powered trucks and outstanding energy efficiency, the Tesla Semi can bring long-term economic benefits to transportation companies while promoting the development of a clean and sustainable transportation system. If Tesla continues to refine and expand the capabilities of the Semi, we will witness a revolution in the transportation industry, where self-driving and fully electric trucks become the standard, gradually replacing fossil fuel-powered vehicles and paving the way for a brighter future for both the industry and the global environment. What do you think about Semi Refresh? What do you expect from Semi version 2? In today's episode, we're going to talk about the Cybertruck, arguably the most controversial vehicle in Tesla's lineup. The truth is, Cybertruck sales are alarmingly declining this year. The company has sold only around 10,000 units so far, compared to about 40,000 units last year. Is the demand for this vehicle practically collapsing? What do you think about the fact that many people aren't buying the Cybertruck simply because they don't have enough space for it? As we all know, people partly dislike the Cybertruck because of its bizarre design. It's quite large and bulky. But the biggest factor behind the drop in demand is its price, which is far beyond the reach of most customers. Even the cheapest version costs nearly $70,000. Design and price are the two main issues keeping demand for the Cybertruck consistently low. And if this trend continues, there's no doubt that the Cybertruck could become the product that contributes most to Tesla's potential risk of bankruptcy. Look, we're big Tesla fans and got a soft spot for the Cybertruck, but let's be real here. Tesla's not just going to sit back and let the Cybertruck flop, and they sure as heck aren't going to let it tank the company. To make the Cybertruck something most people can actually afford, Tesla just dropped a smaller, cheaper version that costs about the same as a Model 3, or even less at $49,990. So, what's this new version got? How'd Tesla strip it down? Let's dive in and find out. Yeah, the Cybertruck's design might stir up some debates, and the price tag's been a tough sell for some. But when it comes to the driving experience, durability, and keeping drivers safe in serious crashes, we'd bet good money the Cybertruck's in a league of its own. Here are a few random comments from Cybertruck owners we stumbled across. Yeah, that's something we can't deny. The Cybertruck does offer features you simply won't find on other Tesla models, like steering by wire. The interior also delivers a premium experience with a central control screen as large as 18.5 inches. However, its high price tag makes all those specs and driving experiences almost meaningless for most people. They just don't get to enjoy these amazing features because they don't have the chance to own such an expensive pickup truck. But price isn't the only issue with the Cybertruck. Currently, Tesla's pickup is only available in North America, not in major markets like Europe or Asia, where Tesla has a significant presence. The main reason is its oversized dimensions, which simply aren't ideal for many narrow streets or varied traffic conditions abroad. Earlier this year, the UK government confiscated one of the first imported Cybertrucks, while another unit in the European Union had to be modified to meet local safety regulations due to its sharp, rigid body design. The truth is, Tesla actually downsized the Cybertruck before starting production and deliveries in November 2023. The original prototype was slightly larger. From what we understand, the size reduction was partly to ensure the vehicle could fit inside Boring Company tunnels. But clearly just shrinking it a bit wasn't enough. for the Cybertruck to make it into markets beyond North America, Tesla really needs a significantly smaller version, and the price needs to come down even further. There's nothing more important than price, and that's exactly why the company decided to develop a smaller version, as confirmed by Tesla's Vice President of Engineering, Lars Moravi. He stated that Tesla will launch a compact pickup, possibly as soon as next year. In fact, Lars Moravi isn't the only one who's talked about it. Elon Musk also hinted a smaller Cybertruck version back in 2019. He teased on X that a smaller version of the Cybertruck could be released in the future. So what's in a smaller version of the Cybertruck? First and foremost, the size and weight of this new version will be significantly adjusted. Although the current Cybertruck comes in multiple motor configurations, it's only available in one size, with an overall length of 223.7 inches, a width of 95 inches, and a height of 70.5 inches. The bed measures 72 inches long and 48 inches wide, while the truck's weight ranges from 6,000 to 6,900 pounds depending on the motor variant. However, the smaller Cybertruck is expected to shrink down to dimensions more in line with mid-size pickups like the Ford Ranger or Toyota Tacoma. Specifically, the new version will reportedly reduce overall length from 223 inches to around 210 inches, and width from 95 inches to just 75 inches, while maintaining the same height. The wheelbase is expected to drop to about 135 to 140 inches, making it more maneuverable in tight spaces. Thanks to its air suspension system, ground clearance could still be maintained at around 16 to 17 inches, ensuring solid off-road capability. Of course, the new version of the Cybertruck won't retain the same sharp, angular exterior as the original design. Instead, it's expected to feature more rounded and streamlined lines, similar to the look of the Ford F-150 or the Rivian R1T. That said, it will still carry Tesla's signature modern aesthetic, thanks to the use of stainless steel body panels. You know, the original angular design was one of Cybertruck's most defining features, but also one of the most controversial. That aggressive styling is a big reason why the vehicle hasn't rolled out more broadly in global markets. In regions like Europe and Asia especially, those sharp edges are seen as a potential danger to pedestrians, and could cause more severe damage to other vehicles in the event of a crash. So, this design change could make the Cybertruck far more acceptable, especially in markets with strict road safety regulations. What do you think about a less angular Cybertruck? Drop a comment below. One of the key factors in reducing production costs is the battery system. The smaller Cybertruck version is expected to use a battery pack with reduced capacity, dropping from 123 kilowatt-hours down to somewhere around 75 to 100 kilowatt-hours. Surprisingly, though, the range won't drop that much. The new Cybertruck should still be able to go over 300 miles. Why is that? The simple answer is that a smaller battery pack doesn't just lower costs, that also significantly reduces the weight of the Cybertruck. Thanks to adjustments in both vehicle size and battery configuration, this version is expected to weigh around 4,500 to 5,000 pounds, with a lighter frame structure. The more weight you cut, the less battery capacity you need to maintain solid range. What we don't yet know is whether Tesla will continue using its 4680 battery cells in this smaller version. As of now, Tesla uses 4680 cells across all Cybertruck variants. While these are known as one of Tesla's in-house battery innovations, they're still relatively expensive to produce. That's why we can't help but question whether Tesla will really stick with 4680s for a more budget-friendly version of the Cybertruck. What do you think? Should Tesla consider switching to a different type of battery for the smaller pickup? As for the powertrain, the compact Cybertruck version will likely offer just two options: a single motor setup producing around 300 to 350 horsepower, and a dual motor configuration delivering about 400 to 450 horsepower. Acceleration from 0 to 60 miles per hour is expected to fall between 4.5 to 6 seconds, powerful enough to compete with today's mid-size pickup trucks. Removing the tri-motor option not only helps cut costs, but also simplifies the drivetrain system, making it easier and more affordable to manufacture. Finally, towing and payload capacity on the compact version will definitely be lower compared to the original Cybertruck, mainly due to the smaller battery and lower-powered motors. This version is expected to tow between 7,000 and 8,000 pounds and carry a payload of 1,500 to 2,000 pounds, which is more than adequate for everyday tasks and shorter trips. Not just the battery and motor, Interior designs and premium features may also be simplified in this version. These are some of our predictions. As we all know, the large 18.5-inch touchscreen is a standout interior feature of the Cybertruck, displaying the speedometer, driver assist systems, infotainment, and more. Its sharp graphics and intuitive menus make the Cybertruck's screen easy to navigate and impressive to show off to friends. However, a smaller Cybertruck doesn't need such a large screen. A display under 15 inches like the one in the Model Y would be more than enough. The 15-speaker audio system could be reduced to 10 speakers. The 9.4-inch rear screen may be eliminated. There would be no steer-by-wire system, and it might use standard non-electric leather seats. The lighting could be monochrome, and the window glass simplified. No more shatterproof windows. Sound insulation would likely be less advanced compared to the current Cybertruck models. With these adjustments, the compact Cybertruck is expected to be at least $20,000 cheaper than the current Cybertruck RWD. That would bring the price down to $49,990, or possibly even lower if Tesla achieves greater efficiency during production. At $49,990, the Cybertruck would easily compete with pickup models like the Ford Ranger or Toyota Tacoma. Its minimalist design with thoughtfully removed features would help Tesla expand its market and appeal to a broader customer base, especially those who don't need a full-sized pickup. This is what we predict could happen with the smaller version of the Cybertruck. While these predictions may turn out to be right or wrong, they're certainly not out of the realm of possibility, especially considering that Tesla is well known for its ability to simplify things in order to cut production costs. Tesla doesn't have much experience in producing low-cost vehicles, but that's exactly the strategy we'll see more clearly when the Model 2 launches later this year, as mentioned during the Q2 earnings call. The Model 2 is expected to be an affordable car that could help turn things around for the company amid declining sales, and as Tesla falls behind BYD. Yeah, this is probably the most accurate depiction we've seen of the Model 2's design so far. Although Elon Musk said it would resemble the Model Y, it's clear that it doesn't look exactly the same. According to what's been revealed about this vehicle, it's expected to be 30% to 35% cheaper than the Model Y, which would make it one of the most affordable electric cars you can buy. We already know some details, not everything, but there's some pretty interesting data coming out of China that gives us a glimpse of what the new Model Y will and won't have. A prototype that was photographed shows the car has a front bumper camera, confirming that it will support full self-driving. The headlights have been moved up from their current lower position on the Model Y, and the full-glass panoramic roof is being eliminated. Some people might not be used to this design, but it's actually quite interesting, although this change may not be the most cost-effective move for the Model 2. It's a major shift, as Tesla will now have to build the entire roof out of steel instead of glass. So yes, that's a big change. No more panoramic glass roof. Of course, the rear screen for passengers is also being removed. We don't think that's really necessary in a budget-friendly car. After all, earlier versions of the Model 3 and Model Y didn't have rear screens either, so this is probably the right call. What about the battery for the Model 2? It looks like it'll use lithium iron phosphate batteries, with a pack size of just 53 to 55 kilowatt-hours. The driving range will likely drop to around 220 miles with the smaller battery pack. We don't think Tesla will go below 200 miles of range. In fact, the range could end up being higher than 220 miles, since the vehicle will use smaller wheels and have a lighter overall weight. This could increase range by around 5%. So, the range of this more affordable version of the Model Y, presumably the Model 2, could reach up to 240 miles by our estimate. That would be a real benefit for users. Most people don't actually need large wheels on a car like this, so that would be a big plus. There's no rear light bar like on the current Model Y, and this is still a four-door vehicle, with dimensions not drastically different from the Model Y. Essentially, the Model 2 will still be a crossover. The desire to buy the car is very high. It's just people don't have enough money in their bank account to buy it. Literally, that is the issue. Not a lack of desire, but a lack of ability. So the more affordable we can make the car, the better, Elon Musk said during the earnings call. Driving sales through more affordable products is crucial, especially as Tesla faces declining demand due to increasing competition and changes to government incentives, at least in its home market, the United States. Tesla's total revenue in Q2 2025 dropped 12% year-over-year to $22.5 billion, while total vehicle deliveries fell 13% compared to the same period last year. In addition to developing new, more affordable and compact vehicles for the mass market, Tesla is also expected to shock the entire industry with the Optimus robot, more specifically, Tesla Optimus version 3. Over the years, Tesla has continuously improved its humanoid robot, from the early versions to the current Optimus Gen 2. Earlier this year, Elon Musk revealed that Tesla aims to produce at least 5,000 Optimus units in 2025. However, during the Q2 2025 earnings call, Musk clarified that once mass production begins, Optimus will feature the version 3 design, which is different from the current Gen 2 Optimus. Musk expressed strong optimism about the potential of Optimus 3, describing its design as exquisite and predicting it will eventually become Tesla's most important product in the long run. He emphasized that the V3 design is nearly flawless, requiring no fundamental changes, and includes all the necessary degrees of freedom to handle complex tasks. Although Tesla has not yet revealed official images of Optimus 3, many expect the robot to feature a modern appearance similar to the slim humanoid concept model introduced in 2021. If so, it's poised to become one of the most advanced tech products on the market. During the Q2 earnings call, Musk emphasized that Optimus 3 will have more degrees of freedom, allowing the robot to move and operate more like a human, with the ability to perform around 3,000 useful tasks. Optimus 3 is expected to far surpass the Gen 2 version. The new design will be lighter and is expected to move faster, thanks to the use of lighter materials or improvements in joint structure. Version 3 will also feature voice support from Grok and display useful status updates and user-requested information. Musk highlighted that every component of Optimus, from the motors and gearboxes to the sensors, has been custom designed based on fundamental physics, as no off-the-shelf parts could meet Tesla's requirements. The company is also leveraging AI technology from its full self-driving system to train Optimus, enabling it to move fluidly, avoid obstacles, and build environmental maps on its own. Regarding production plans, Musk said Tesla will begin building Optimus 3 prototypes by the end of 2025, with mass production ramping up in 2026. He predicted that Tesla could be producing 100,000 robots per month by 2030, though he acknowledged that the first 1 to 2 years will be challenging due to supply chain issues or internal errors. As for pricing, Musk has previously mentioned a target price of $20,000 for Optimus, though some estimates suggest Optimus Viv 3 could cost up to $50,000. Still, with its ability to carry out thousands of tasks, from cleaning and elder care to factory assistance, Optimus could offer major savings on labor costs. For example, a worker in the U.S. earns about $35,000 per year, while Optimus only needs a 20-minute charge to run for 8 straight hours. Above all, Optimus 5.3 is not just a piece of technology. It has the potential to fundamentally change the way people work and live. By automating repetitive or dangerous tasks, Optimus could reduce reliance on manual labor, boost productivity, and lower costs. However, it also raises concerns about employment, as industries like manufacturing, healthcare, and warehousing could face disruption. Even so, Optimus also opens up new opportunities in fields like robotics research, development, maintenance, and creative industries. Tesla was once the top competitor to China's giant BYD, but now many people believe it might be more interesting to compare BYD to Geely. Tesla is something of a spent force. Yeah, it's no secret that this has truly been one of the worst years for Tesla and Elon Musk. Sales have dropped sharply while Musk has been constantly involved in political controversies. Here's a chart comparing the BEV sales of Tesla and BYD from 2022 to today. BYD overtook Tesla in 2023, and history seems set to repeat itself this year. At this point, there are many calls for Tesla to release the Model 2, the only car that could change the game, as it's clear that millions of people would buy it at the price of $24,990. Elon Musk had confirmed that this would be the car produced in the highest volume, matching the combined numbers of the Model 3 and Model Y, with an overall target of 42 million units. However, since this car uses LFP batteries to reduce costs, Tesla needs a large supply chain in the US to avoid expensive tariffs from China. Yeah, and this is why the new Tesla LFP battery factory will be responsible for supplying batteries for Tesla's affordable vehicle. So, what's inside this factory, and why is it a good fit for the Tesla Model 2? Okay, Tesla Master Plan. Part 3 not only reveals the production target of 42 million for the affordable compact car, but also lists the type of battery this car will use. The 53 kilowatt-hour LFP battery is a perfect fit for the minimalist criteria set by Elon Musk for this car. LFP is currently one of the cheapest battery types for EVs, but importing it from China and using it in an electric car in the US makes it less affordable and makes producing a $25,000 car seem unfeasible. Therefore, Tesla will ultimately produce the LFP battery for the Model 2 in the US. The truth is, not many of us really know about this factory. It could be said that it was built quietly. As we know, a 25% tariff has been applied to batteries from China, but this rate increased to over 80% during the Trump administration before he temporarily suspended some tariffs on China. It's still unclear what the tariff situation will be once negotiations are completed and the trade war is resolved, but many predict the tariffs will remain high. Therefore, manufacturing batteries in the US seems to be a smart move for Tesla. Tesla has completed most of the factory construction and has the necessary equipment inside to produce lithium iron phosphate batteries. Notably, Tesla has purchased all the equipment from China, specifically from CATL, the world's largest battery manufacturer and a key partner of Tesla. CATL started producing LFP batteries quite some time ago. But what's interesting is that this technology was originally invented by Americans. Ironically, even though LFP technology was invented by Americans, it wasn't prioritized for development in the US. Americans invented lithium phosphate batteries, but they did not give the technology the attention and investment needed for its development and optimization. Not just in the US, but most Western countries considered lithium phosphate batteries to be junk and unworthy of use in electric vehicles. This partly stemmed from the fact that LFP batteries have a relatively low energy density of just 140 watt-hours per kilogram. However, Chinese manufacturers, particularly CATL, saw great potential in this technology and quickly took over and developed it strongly, even with its limited energy density. Despite this drawback, CATL recognized that the LFP battery could still offer high efficiency at a low production cost, while leveraging the battery's stability and long lifespan, with the understanding that the low energy density could be improved over time. China later patented the lithium phosphate battery technology, and today, over 70% of the batteries produced in China are lithium phosphate batteries. As we mentioned earlier, LFP is much cheaper than the batteries produced in the US, where the primary battery type is lithium NMC, which contains nickel, manganese, and cobalt. This is the type of battery used in Tesla's Model 3 and Model Y performance versions. On the other hand, lithium phosphate batteries don't require nickel or cobalt, which is the main reason they are so much cheaper to produce. Now, over 70% of electric vehicles produced in China use lithium phosphate batteries, and for Tesla, more than 70% of the cars sold globally also use this type of battery, most of which are not produced in the US, but in China. Tesla has now purchased the entire lithium phosphate battery production line, including all the necessary equipment and robots, and has built a factory in Nevada. This factory will produce the battery cells. What Tesla is doing is collaborating with CATL, the world's largest battery manufacturer, which holds about 38% of the global battery market share. They are sending people to train American staff on how to operate the production line. As far as we know, this is happening right now. Chinese engineers are either already in the US or are on their way to train American workers at the Nevada factory on how to produce lithium phosphate batteries. Once the training process is complete, they will return to China, and Tesla will pay a royalty fee, possibly 5%, though the exact figure is still unclear. The production cost of lithium phosphate batteries is still much lower compared to Tesla's 4680 or 2170 batteries, or even batteries imported from Panasonic. As of early this year, the price of LFP batteries was just $85 per kilowatt hour, while NMC or NCA batteries cost up to $120 per kilowatt hour. Therefore, initially, Tesla will use these batteries for its lower-priced models and could also use them for the standard versions of the Model 3 and Model Y after the federal tax credit expires. These versions will have a shorter range but will be priced much lower. Tesla often relied on the $7,500 tax credit as a discount when customers purchased EVs, which made the cars feel more affordable. Now that the tax credit program has ended, Tesla needs to reduce the price of its electric vehicles on its own, and using LFP batteries is the ideal solution. With a cost of just $85 per kilowatt hour, a 53 kilowatt hour battery pack for the Model 2 would only cost about $4,500 of its total $24,990 price. This means the battery pack makes up only about 18% of the vehicle's cost. The Model 2 is expected to be equipped with a 53 kilowatt hour battery, giving the vehicle a range of about 250 miles. However, thanks to its lighter weight and more streamlined, efficient design, the Model 2 will have higher aerodynamics, which will add at least 30 miles to the range. This gives a total range of about 280 miles, a perfectly suitable figure for a mainstream electric vehicle, meeting the daily driving needs of most users. What do you think about this range? Is it convincing enough for you? From our perspective, observing opinions about Tesla's affordable car, a price difference of a few $1,000s could really make a difference. Many consumers have expressed that they would be satisfied with a Tesla offering a range of 200 to 250 miles, but priced over $1,000 less than an EV with a range of 300 to 350 miles. Simply put, the daily commuting needs of most people today are under 200 miles. What's particularly notable is that LFP batteries stand out for their fast charging capabilities even in cold weather. The Model 2 will be able to charge up to 80% in just about 20 minutes when using Tesla's supercharger stations. This is one of the strengths that helps Model 2 strongly compete with other EVs in the mainstream segment, especially when it comes to fast charging times and long-range capabilities. Inside Tesla's lithium iron phosphate battery factory in Sparks, Nevada, a highly automated and modern manufacturing process takes place to create efficient, sustainable, and cost-effective batteries for electric vehicles and energy storage systems. The production line is organized into key stages, including raw material preparation, electrode production, cell assembly, and quality testing. Almost everything is automated to 95%. Raw materials such as lithium hydroxide, phosphate, and iron are mixed in precise ratios in chemical reactors. Graphite, a key component for the anode, is sourced from domestic or environmentally friendly mines, helping reduce the ecological impact compared to cobalt and nickel-based batteries. Highly automated production lines controlled by artificial intelligence ensure precision in cutting, layering, and assembling the LFP cells. Each cell is designed with a cell-to-pack structure, eliminating intermediary modules to increase energy density and reduce weight, contributing to enhanced energy density. After assembly, the battery cells undergo an electrochemical activation process, where they are charged for the first time to test performance and stability. The quality control system uses sensor and AI algorithms to detect micro defects, ensuring the batteries meet high safety standards with a thermal operating threshold of up to 270 degrees Celsius, which is superior to the 150 to 210 degrees Celsius range of NMC batteries. The factory operates on renewable energy from solar and geothermal power, aligning with Tesla's sustainability goals. There are rumors that the initial production capacity is 10 gigawatt hours per year. While this number is still relatively small by Tesla's standards, it is a highly significant initial investment. Tesla will significantly ramp up the production of in-house LFP prismatic cells and may apply some of the learnings from the Dry 4680 production line in Austin. In addition to EVs, Tesla will use LFP batteries for energy storage products, specifically the Powerwall and Megapack, which are designed to store electricity for homes or large power systems. These systems typically capture energy from solar panels during the day, store it in the Powerwall, and use it at night. Relying on Chinese manufacturers is not ideal, and is especially complicated for American automakers and battery producers like Tesla, especially amidst the ongoing trade war between the US and virtually the entire world. including China. However, this does not mean that Tesla will only focus on creating low-cost electric vehicles with LFP batteries. Similar to gasoline-powered vehicles, there will likely be two distinct branches. LFP batteries will primarily be used for more affordable, mainstream cars, while the 4680 battery will be used for performance and higher-end vehicles. Although Tesla's affordable car has yet to be released, it has been consistently camouflaged for testing around the Fremont factory area recently. There are several notable features on this camouflaged car that suggest it is the Model 2, the affordable vehicle we've all been waiting for. Based on its overall size from the images found, especially when compared to the Model Y cars parked nearby, it is clear that it looks significantly smaller than the current Model Y, possibly even at least 20% smaller than the older Model Y version. This is clearly not the Model Y performance variant, as we know that version would have a camera on the front bumper, whereas the cars that have been found do not. Additionally, many have observed that the wheels are noticeably smaller, looking like 18-inch wheels, which are smaller than the standard wheels on the current Model Y. Discussions also suggest that this car will only have two doors, as no rear doors were detected in the camouflaged images. While it's not certain, as a team with years of observing Tesla, we have concluded that they only camouflage the car when it's a new model. They don't want anyone to spot it, as it would affect the sales of other models, especially given Tesla's unstable revenue this year, as we mentioned at the start of the video. Additionally, we have some speculations about this vehicle, which may be right or wrong, but in our opinion, they are very likely based on Tesla's pricing and design trends. First, this car could be a hatchback, with the design featuring a light bar similar to the Model Y and Cybertruck, and an overall length of around 157 inches. The Model 2 is expected to be equipped with single-pane windows on both sides instead of the double-pane windows, and interior lighting will likely be a single color, instead of the 256 color options available on the two Model 3 and Y. The seats will likely be fabric, without heating or ventilation, which alone could reduce the cost by around $500. The audio system in this car will also be more basic, with 7 speakers, fewer than the 7 speakers in the other car 14 speakers found in the standard Model Y. It seems the Model 2 will only be equipped with a single motor, aligning with Tesla's goal of creating an affordable electric vehicle while maintaining reasonable performance. 2 years ago, Tesla announced they were developing a motor priced at just $1,000 for mass-market vehicles. While Elon Musk didn't reveal many details about this motor, if Tesla is still working on it, this could be the perfect fit for the Model 2. With this motor, the Model 2 could take about 7 seconds to accelerate from 0 to 60 miles per hour. While this figure may not be as impressive compared to sports cars or high-end electric vehicles, it is a reasonable number for an affordable electric car, especially when considering its performance and production costs. Ultimately, the Model 2 will still have the necessary setup to support FSD features, allowing owners to earn money when not using the car through Tesla's robo-taxi network. These are our speculations about the vehicle, which could be right or wrong, so we'll have to wait for it to break free from its camouflage layers. If Tesla manages to release the Model 2 at an affordable price this year, it could have an extremely positive impact, especially considering the company's Q1 revenue dropped by 70%, and Q2 sales haven't shown significant improvement. Many believe the Model 2 could be Tesla's savior, as the demand for this car will likely be huge, especially with its focus on the mass-market electric vehicle segment, making it accessible to a broader range of consumers. Based on leaked images near Fremont, we believe this will be the factory responsible for producing this car, rather than the Giga Texas. With advanced manufacturing technology from Giga Shanghai, where the Model Y can be produced in just 33 seconds, we believe that the Model 2 could be manufactured even faster, in just 20 seconds. This is entirely feasible because the Model 2 has far fewer parts than the Model Y, and is optimized for a production line that focuses on low cost and high efficiency. The Giga Press allows Tesla to cast large sections of the car's frame, such as the entire lower body or rear body, as a single piece, rather than assembling them from hundreds of individual parts. This technology significantly reduces production time, labor costs, and the number of welds while enhancing the durability and accuracy of the car's structure. With the Model 2, GigaPress helps to further optimize production costs. It's truly exciting to see the production of LFP batteries being brought to the US. This will not only help Tesla reduce its dependency on battery supplies from China, but also open up opportunities to enhance supply chain autonomy. LFP batteries are a key technology, not just for energy storage, but also for standard electric vehicles with lower ranges. This is due to their high safety profile, long lifespan, and most notably, their much lower cost compared to nickel-based batteries. With these advantages, LFP batteries are becoming an increasingly popular choice for affordable electric vehicles, helping reduce production costs and making electric cars more accessible to the majority of consumers. Let me know your thoughts in the comments below. What do you think about this development and the potential of LFP batteries in the EV industry? We hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Tesla Car World family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.